We're finally at our final lesson for this series of lessons, exponents moving into order. Lesson 2-10, if you're following the applied algebra curriculum, dealing with the order of operations. And yeah, fractions had to come back and rear their ugly head again. So we're going to deal with the worst last. Saved it for last, but I know people don't like fractions that much, but you have to deal with them. You have to practice them to get better, so they're going to keep coming back. We'll keep working on them. In this case, we know what to do to these individually, but then I'm going to have to add them in the end, which is where the order of operations comes into play. But let's go ahead and rewrite. We know that 2/3 the squared, so we're doing actually parentheses and kind of the exponents here. We have to deal with the parenthesis first, and this parenthesis is telling us to do whatever that says to everything in here. So rewrite it as 2 squared over 3 squared. Same thing here. It's telling us to raise to the third power everything that's in here. So -2, I'm going to go ahead and put that in parentheses because it's operating on that as well, over 3 to the third power. So I'm done with basically parentheses. Now it's time to apply the exponents. 2 squared is 4. 2 to the second power is 4. 3 to the second power is 9, plus -2 to the third power. We know a negative raised to the third power is going to end up being negative. So I'm going to put it back in parentheses. 2 to the third power is 2 times 2 is 4 times 2 is 8. Over 3 to the third power, by now, you probably got that one memorized as 27. 3 times 3 is 9, times 3 is 27. We're not done because we have addition in this one. And unfortunately, we have to add fractions, which is probably, and I'll just give it to you. I agree, it's one of the worst things you ever have to do in math, is add fractions. There are things later that can be a little bit more annoying, but for now this is the most annoying. And when we add, the reason addition is annoying because we have to find a common denominator, so it adds an extra burden, an extra step. The common denominator between 9 and 27 happens to be 27, because 9 times 3 is 27, so it works out good. Since we multiplied 9 times 3 to get the bottom, we have to multiply the top by 3 also. 4 times 3 is 12. This one we didn't change the bottom, so we don't change the top either. So it's 12 27ths plus a -8 27ths. Now, hopefully you remember when we add fractions, the denominator stays the same for reasons that hopefully were explained well to you. If not, you may want to ask your teacher to re-explain that to you so you can understand it. 12 plus -8, we know by applying the rules of sign numbers, we take the difference, which is 4. 12 is more powerful, so it ends up being a +4 over 27. Now, if you're feeling good about these, you're welcome to stop the video and move on to the practice. Get that feedback and see how you're doing. But I'm going to show you one more example of how fractions can come into play in the order. This one is, at least at the onset, a little easier. You'll see why. It's a 3. There's some multiplication in fractions there, which is considerably easier than addition or subtraction, but still going to make you add or subtract. So we'll review that again quickly. So let's just start. Parentheses, they're there. There's nothing to do inside them, so they're only communicating multiplication. There's no exponent. There's no operation inside there. Now, if I was going to allow you to work in decimals, this would be a place where you would divide 2 divided by 3 to turn it into a decimal, -3 divided by 5 to turn it into a decimal. Now would be the time, because that would be multiplication and division, and inside parentheses it's telling you to divide that before you do anything else. But I'm making you work in fractions, so that's off the table. Fortunately, to multiply these two is pretty simple. When you multiply fractions, you just multiply the top and you multiply the bottom. It's that simple. When you add or subtract, of course, the bottom stays the same, which can be confusing. When you multiply, it changes. When you add or subtract, once I get a common denominator, it doesn't change. Again, adding to the confusion, which hopefully that's been explained to you well. If not, have a conversation with your teacher. So let's go ahead and find our common denominator, because now we're subtracting or adding the opposite, which is the last thing in the order of operations. Common denominator between 15 and 10 happens to be 30, because 15 times 2 is 30, 10 times 3 is 30, and that's the first one that comes, so we're going to use it. still plus a negative. 15 times 2 is 30. So I got to multiply a negative 6 times 2, which gives me negative 12. 10 times 3 is 30, so I got to multiply negative 3 times 3, which gives me a negative 9. I already had the negative up there because I knew it was going to be negative. Now all that's left to do is add those numbers up. Since they're both negative, I add the absolute value, which is 21. They're both negative, making the final answer negative 21 over, and we see the denominator doesn't change. Negative 21 over 30 is the answer. Now finishes up this contingency of exponents moving into order of operations. Hopefully you've gotten a lot of practice. If you're still feeling a little bit iffy about it, go back and get some more practice. Just keep working on it. It's kind of the way math works. The more you practice, the more it's going to come to you. Eventually you'll get it if you just don't give up and you keep working it.